students, today we will learn the gravitational field and the intensity of gravitational field. So what is gravitational field? Gravitational field is a space around the mass or a body which experiences the gravitational force of attraction. So it is one field. So let us consider one body of a mass m. If it is this body is experiencing the force of attraction, so there must be a sum around this unit mass, so which will experience the force of attraction. So force of attraction between the two bodies or any other bodies attracts the other kind of a body. So that is attraction force. Gravitational force is not only those bodies we have already considered. It is one of the responsible reason. It is one of the responsible reason that around the bodies, the nature, space around these bodies are responsible to create the force of attraction. So that is nothing but any one of the body or a considered body, space around that body experiences the gravitational force of attraction. That field or that space we call it as a gravitational field. So what is that? Whatever may be the body or whatever may be the considered mass object in this, it's experiencing the gravitational force or force of attraction. Means it is not only those bodies attraction takes place. The space around those bodies which is responsible for gravitational force of attraction, that is called as gravitational field. The space, nature, attraction around the that is the body which is also responsible to develop the force that is attracting to the bodies here. That is gravitational field. So intensity of gravitational field means if you consider the unit mass or a unit body whose mass is m here, when you place at such a point in the gravitational field, so presence of that unit mass does not affect that original gravitational field. That means, so once you consider the body whose mass is m here, so you have placed in a gravitational field. That you know here what is gravitational field. The space around the body which experiences the gravitational force of attraction. That is called as gravitational field. Once you place that unit mass of the body here in such a gravitational field, so the presence of that unit mass does not affect that original gravitational field. Means the presence of that body does not affect. So gravitational field will do its duty. That is what it to develop the force of attraction between the bodies here. So this is one of the important concept for gravitational force of attraction. So field is also very responsible to develop the force of attraction between the bodies here. That field is called as a gravitational field. Then intensity of gravitational field means that is nothing, whatever may be the mass, whatever may be the object whose mass will be taken as a unit mass. Why I am considering here unit mass means if you consider the unit mass, a single mass, so once it is placed in that gravitational field at that point which is responsible to develop the gravitational force of attraction, that presence of that unit mass does not affect the whole gravitational field. So that is the intensity of gravitational field. It does not affect the presence of unit mass which is you may feel it as or we feel it as it will affect the gravitational field. No, it is not affecting. It will be doing its duty, that is developing the gravitational force of attraction. Now comes here, as we understood here, intensity of gravitational field, presence of unit mass does not affect the original gravitational field. The presence of unit mass. So what is that? The F, E is equal to intensity of gravitational field. F is equal to F by m naught. What is this F? F is nothing but the force of attraction. M naught is the mass of the unit mass I have considered here. M naught. Now it is a vector form of this intensity of gravitational field. What do you write here? The symbol of vector here. So vector E is equal to intensity of gravitational force vector F by m naught. So this is the let us consider here Earth surface. On that Earth surface, we'll consider one body whose mass will be m here, right? And let be r be the radius of the Earth. Now, around these two bodies, the field will be there. That is nothing but your gravitational field. What is that? The space around the body which is responsible or experiences the gravitational force of attraction, that is called as the gravitational field. And the presence of unit mass in the gravitational field does not affect its original gravitational field. That is the intensity of gravitational field that we have just recognized here or realized. Now, intensity of gravitational field on the surface of the Earth. On the surface of the Earth. So, what will be the gravitational field? So, if you consider the body on the surface of the Earth whose mass is a m and r be the radius of the Earth and capital M be the mass of the Earth here. Now, according to the Newton's law of gravitation, let us consider the body of a mass m here, which is on the surface of the Earth whose mass is a capital M and let r be the radius of it. According to the Newton's law of gravitation, force is directly proportional to the product of their masses. So we'll write it here F is equal to Gm small m divided by r square here. Now we have intensity of gravitational field. So what we have, capital E is equal to F by m. M not I have not taken here because we have taken the mass on the surface of the Earth whose mass is m. If m not is there means let understood that it is a unit mass in the gravitational field. So let us consider this is the equation 2 and previous one is the equation 1. Now intensity of gravitational field intensity of gravitational field is the equation number 2. Then substitute the F value in E is equal to F is what? Gm capital M small m r square. Now what it will be here? E is equal to, so that will be F will be force of attraction. E is Gm n small m r square into 1 by m here. Small m will get cancels each other. Then remains with the capital Gm by r square. So this is nothing but the intensity of gravitational field on the surface of the Earth. So similarly, you will get intensity of gravitational field. So once you understood the gravitational field, what do you mean by gravitational field? What we can understand by the intensity of gravitational field? Then we can easily realize what will be the intensity of gravitational field if the body is on the surface of the Earth. So very simple it is, the force which is responsible for the attraction to each other or the attraction of between the bodies, what we have calculated or what we have considered, that is not only the force which is developed from the center of the bodies, it is the space around the bodies which is also one of the responsible reason which will get the gravitational force of attraction. It is a vector quantity, it is always directed towards the center of the body whose gravitational field is considered here. Now we know acceleration due to gravity on the surface of the Earth, what will be there, and similarly the intensity of gravitational field on the surface, what is that? So let me cross check here acceleration due to gravity or the acceleration due to gravity on the surface of the Earth. Acceleration due to gravity. Acceleration due to gravity on the surface of Earth. The surface of Earth is small g is equal to Gm by r square. So similarly, intensity of gravitational field on the surface of the Earth, just now we have expressed the form here. What is that? E is equal to Gm by r square. Just look at both the expression, both are equal to each other. That indicates here acceleration due to gravity on the surface of Earth is equal to intensity of gravitational field on the surface of the Earth. This is very important here. What is the intensity of gravitational field? What is gravitational field? That we have to understood very thoroughly so that next what will be the intensity of gravitational field on the surface of the earth? Is it related to the acceleration due to gravity of a body on the surface of the earth? So it is obviously very much related to each other. As we know, acceleration due to gravity, if the body is on the surface of the earth, it is directly related to the gravitational constant, mass of the earth's surface, I mean the earth, okay, and r will be the square of the distance between the body and the earth here. So similarly, as we find the gravitational field, so how much intensity of gravitational field will be there on the surface of the earth? Just we have considered the body on the surface of the earth here. So according to the Newton's law of gravitational force, we have got the force here, F is equal to m by r square. We have the intensity of gravitational field, that is F by m, that is force by unit mass. I need to say that mass we have considered on the gravitational field. So it is always directed towards the center of the body whose gravitational field is considered here. Then acceleration due to gravity on the surface is obviously equal to the intensity of gravitational field on the surface of the earth. So that amount of work done in bringing the body of a unit mass from infinity to that point in the gravitational field, that is denoted by V here, means the body is there away from the gravitational field. So we have to do some work here, amount of work done in bringing the mass of unit mass of a body or a body of a unit mass from infinity to that point where the gravitational field is there. To that point in a gravitational field, it is denoted by capital V. So what V is? V is equal to work done. So work done by masses. So look at here. If you consider the one body of a mass m here, right? Consider another body. So let be a point here A. So it is some distance it is there. So it is maintained from the some distance here. So we will tell what distance it is, right? So amount of work done in bringing the unit mass, body of a unit mass from infinity. So let us consider here maybe infinity, in that range it is. From infinity to that point. So this is a point P where the gravitational field exists. So bringing amount of work done in bringing the body of a unit mass to that point where the gravitational field is exists, or gravitational field which experiences the force of attraction between the bodies here. So what we have to do to bring this point here, means body has to take from that point where it is infinity or it is in the range of infinity, will bring that body to that point. So which point? Where the gravitational field is exists, or the where the gravitational field develops. So begins it. So before making that body to come from directly infinity to that point, we have to do small work here. Means we have to do small work done in bringing the unit mass for the small distance, that is point B here. So what is this distance? This distance we call it as it is a dr. Small distance, small work will be done here. So this space, so distance between the point P, that we call it as it is a r. So distance from that point to where the point is already there. So that is nothing but the x here, the distance between the body capital M and where the body is in the infinity range. We have to do some work to bring that body of a unit mass in that point where the gravitational field is exerts the gravitational force of attraction between the body of a mass capital M and with the body of mass M here. So that is called as gravitational potential. What is that? Gravitational potential. Amount of work done in bringing the unit mass of a body from the infinity to that point where the gravitational field is there. So that is very important. As we know here, the distance between these two bodies is x. The point P is called as a gravitational field point. So So we have to bring that unit mass from infinity range to or infinity point to that point. So directly we can't bring to that point. We have to test whether it will take place a displacement by doing a small work done. So that small work done we will denote it as dW. Okay, small work done. First we will check whether it will be displacement takes place or not. So that is called as small displacement. Okay, so small work that we are doing to take a how the process is taking place. That diagram is very small, so I have made it as just larger here. So let us consider the body of a unit mass m0. I have noted here m0. So that is there in the infinity range. So that is there in the infinity range. Amount of work done in bringing the body of a unit mass from the infinity point or from the infinity range to the particular point. That is there in the gravitational field. We have to bring that unit mass from infinity range to that point where the gravitational field exists or where the gravitational field will create or develop the force of attraction between the body and the considered unit mass here. So to do that work, we can't do or we can't make the so much work suddenly. It has to jump from the infinity range to the gravitational point or gravitational field point. We have to do some work here, very small work we have to do, so that small displacement takes place. So now I will take it as this is a small displacement. What means from the point A, where it is in the infinity range, it has to bring to the small point, so which is possible after doing some work, it is possible to take the small displacement. So that is dx is a very small displacement with a very small work done. dw is a small work done in bringing the unit mass from the infinity range to that particular point. So that is a small displacement, that is dx here. So according to the again Newton's law of gravitation, F, the force of attraction, is G capital M and m0 divided by x whole square here. What is mean capital M here? The body whose mass is capital M. The body what we have taken here unit mass m0 here. The force of attraction between these two by separated by some distance x here. That is g m m0 x square here. It is, let me say it is a equation 1. Now gravitational potential energy work done by m here. So we have to show here small work has to be done. That is dw, work done in bringing the amount of amount of work done in bringing the unit mass from the infinity range to the particular point. That is work done is what? Force into displacement. So force into displacement it is. So what is force? Force is there here. So W means small work done. So F into dx it is. So what is F? G m m0 by x square here. So it is a dx. Now what we have to do here, this is about the small work done. Right? Small work done means small displacement. We want a total work done in bringing the unit mass from the infinity range to the particular gravitational field point. It is where it has to take place the force of attraction between the mass whose mass between the body of a mass capital M and consider unit mass m0. Now what we have to do? Total work done. How much work we have to do so that it has to take place gravitational force of attraction between those bodies which is separated by maximum range, that is capital X. It has to be come to the part of at the point P here. Now what we have to do? We have to go for the integration. So what is that? Integration we have to go ahead. With the help of integration of small work done. Right? So integration of G m m0 by x square into dx it is. Now what we have partial integration, we will say that this one. What is that? From one range to another range. What we are doing here? We are taking the small work done from infinity range to the small distance at a range it is. Or we can say that total work done in bringing the unit mass from infinity to that point where the gravitational field is there, or it is responsible to develop the gravitational force of attraction between that considered unit body and the capital M of a mass body here. That is what range between the point P and the mass M here. What is the distance? Small r. So what is that? Infinity to r it is. We have to mention it here. Infinity to r. Now I will show it here. Partial integration. What we are doing? Small work done. Integration. Small force into dr here. What is force? G capital M small m m naught by x square dr. So integration of dw. So from the range infinity to r. I explained here. We are doing the work here. Total work done in bringing the body of a unit mass from the infinity to that point where the distance between the mass of a body capital M is r. That distance done. So integration of dw, we can write it here, w here. I will take out gm m naught, which is variable here. X square is variable. So 1 divided by, directly we have taken here. So general form of integration of 1 by x raised to 2. We have noted here general form of integration of x raised to n is equal to x raised to n plus 1 divided by n plus 1. So if it is integration of 1 by x raised to n is equal to integration of x raised to minus n, we can write it here x raised to n minus n plus 1 divided by minus n plus 1. So similarly we can apply for this. Integration of x raised to minus 2 is equal to x raised to minus 2 plus 1 divided by minus 2 plus 1. That you will get it here x raised to minus 1 divided by minus 1. So similarly we are getting here x raised to minus 1 divided by 1, that is equal to minus 1 by x. Generally, directly I am writing here x raised to, generally I am writing here 1 by x minus, I will write here minus gm m naught, so 1 by x infinity to r. So what we get it here? Minus gm m naught. So first we take the final point, then after the initial one. So in place of x I will place here r. So r minus of 1 by infinity. So what will we get it here? Minus gm m naught by r here. So we have, so this will give you total work done in bringing the amount of unit charge or amount of unit mass from infinity range to the particular point. This is work done, total work done it is. We have the gravitational potential V is equal to work done by mass, or we can say that unit mass. So what is that? Minus gm m naught by r. So what is this? 1 by m naught. So what we will get? Finally minus gm m naught by r here. So m naught is not there, it is going to cancel. So we will get finally V is equal to, gravitational potential is equal to minus gm by r. So this will tells the gravitational potential. So amount of work done in bringing the unit charge from infinity to that particular point. Now we want to know that gravitational potential here, and what will be the gravitational potential of a body that we have studied here. Now we will move towards the gravitational potential energy. Once you understood the gravitational potential, it is very easy to understand how the gravitational potential energy will also be executing here. So what is the potential energy? Potential energy is nothing but the storage energy here. So gravitational potential energy of a particle gravitational potential energy of a particle, it may be any point on the gravitational field. So that is defined as amount of work done in bringing the particle from the range of infinity to that particular point where we can say that gravitational potential energy will be there for that particular point, that is responsible to again create the gravitational force of attraction between the bodies here, considered bodies. Again we'll take the same diagram here. Let us consider the body of a mass m here and consider the body of a unit mass. Instead of taking m naught here, we'll take the m to get identified what is gravitational potential and what is gravitational potential energy. So let us consider the body of a unit mass m. It is in the range of infinity here. Now let me point B where the gravitational field is exhibits at a distance of r from the body whose mass is a capital M. The unit mass is a kept a separated or kept a distance of x here, will do small work. So gravitational potential energy of a particle may be at any point on the gravitational field will be again it is defined as amount of work done in bringing the unit mass of a body from infinity range to that particular point. We get exactly how much energy is stored in that particle in the gravitational field. That is nothing but the gravitational potential energy. So potential energy itself tells that it is a storage energy. Now let us move towards the again understand how work will be done. So again small amount of work will be doing here to displace the unit mass from the point A to the point B. That is called a small distance. That is dx only we consider, or else we can take it as it is a dr. So to understand or to get separation from gravitational potential and gravitational potential energy here. So dx will consider. So dr will consider here. Now again the force of attraction between the body m whose mass is m here and the unit mass. So force that is equal to g capital M small m and the distance is x square here. So capital X only will take it here. Let me take it as this is the equation 1. So amount of work done. So that small work done we will take it as force into displacement. So work is force into displacement here. So dr will plays the role of small displacement. dw is a small amount of work we are going to do to displace from the body point A to point B here. Now let's take what will be the force. So G capital M small m x square here, right, dr. So dr here. So dw. So this will be the small amount of work done here. Now we'll take the integration of it. Integration of Gm small m of x square dr. Again where from infinity to r it is. This is called as a partial integration. Now you already know here dw can be written as a w here because integration of dw is w. So that is I will take out Gm small m from infinity to r it is. What is here variable x raised to 2. 1 divided by x raised to 2 it is. Now again same. Again last part we have not understood. Again we will check it here. X raised to 1 by x raised to 2 here. We can also write it here. Integration of x raised to minus 2. How it will be written? X raised to minus 2 plus 1 divided by minus 2 plus 1. This is the general formula of integration. Similarly, directly we are going to write here x raised to minus 1 divided by minus 2. So what we will get it here? G m here small m. So 1 by x. So minus sign will be getting here. W is equal to minus sign. So infinity to r. Again final will be written first part in the partial integration here. So 1 by r minus 1 by infinity here. So W is equal to minus Gm, capital M, small m divided by R. So this is again amount of work done in bringing the body of a mass m here for the point P. What is this? W, total work done in bringing the body of a mass m or a unique mass to the point P, where it is separated from the body whose mass is a capital 1, which is in the gravitational field or gravitational potential particles. It will develop the gravitational force of attraction between the body whose mass is a small m and the capital M mass of the body here. So that is nothing but the work done here. So as we know, potential energy is a storage energy. What we have here, potential energy is nothing but the storage energy here. So total amount of work done in bringing the amount of unit mass of a body to that particular point where the gravitational field is there. That is nothing but W is equal to minus G capital M. So here we will write it properly, capital M small m divided by R. So this is nothing but the total work done in bringing the amount of unit mass to that particular point. So this amount of work done only, it is stored as on the particle, or else we can say that it is a body. So this work done will be stored in that body or a particle as a gravitational field, or else we can say that gravitational potential, or else we can say that it is a gravitational potential. So that is nothing but W is equal to this potential energy. That is nothing but the minus G capital M small m by R. So amount of work done itself will place the role on the particle or the body as a gravitational potential energy here. So it will be remains as a same work done is equal to potential energy. It will remains as a gravitational potential energy. See, look at here, negative signs. Since negative signs comes here, it is not against the gravitational force. So gravitational potential energy, it is not against the gravitational force, which is attractive in nature. So as R increases, potential energy is also increases. If R is equal to infinity, see, look at here, R is equal to infinity means potential energy will also is equal to 0. It is. If R increases, potential energy is also increases. Means it is directly proportional here. Depending upon the gravitational potential energy is nothing but the amount of work done. So this work done itself in the particle will play the role of storage energy, gravitational potential energy it is. So this is very important as point of your examination also, as a point of your competitive part also. This is very important. Now let's move on to the what is the relation between gravitational potential and gravitational potential energy. So what is so let us start the relation between the gravitational potential energy and the gravitational potential. So gravitational potential energy, what we have, minus G capital M small m by R. So again gravitational potential is minus Gm by R. Now how they are related? U by V. U is what? Gravitational potential energy. V is the gravitational potential. So minus Gm small m by R. So directly I will take it here, R by Gm here. So minus. So minus is there here. So what it will happen? Gm, R get cancels. So U, V. So it will get cancels. Sign also will be remains as positive only here. Both the sides negative are there. Remains with a small m. So U is equal to M into V. So what is this? Gravitational potential energy is equal to the product of mass and gravitational potential. So this is the biggest and very important gravitational potential energy. Gravitational potential energy is equal to product of mass and gravitational potential. Gravitational potential. So this is the final relationship between the gravitational potential energy and the gravitational potential. So once we have to understand what is gravitational potential energy and gravitational potential, we can easily find out the relation between them, and this is very important. As per then finally we got it as a gravitational potential energy is equal to product of the mass and the gravitational potential. So this is very important as per point of your competitive exam. Escape velocity. The body which is having the minimum velocity which is projected in such a way that it will escape from the gravitational pull of the earth. So body which is having minimum velocity that is projected in such a way that it will get escape from the gravitational pull of the earth. That means nothing but the velocity is escape velocity. Let us consider here one body. So let us consider the body whose mass is m and it is maintained a certain height from the earth. So what is that? It is maintained a certain height from the earth and the radius radius of the earth is r here. The r is what? The distance between the bodies from the center of the earth is small r here. So it has some velocity. It will try to escape from the gravitational pull of the earth. So for that it has to do some work here. Until and unless work has to be done, the body will not escape from the gravitational pull of the earth. That means body has some minimum velocity. If it is projected in such a way that it will escape from the gravitational pull of the earth, that velocity, that minimum velocity, we call it as it is a escape velocity. So let us understand here, to get away from the gravitational pull of the earth, this body, it has to take place some velocity, means some velocity should execute. That is possible only when it is projected. So minimum velocity when body is projected in such a way that it will escape from the gravitational pull of the earth. So for that we need to do some work here. So let us consider the body is having the mass m which is already maintaining certain height from the surface of the earth here. If you do small work, so it will move towards the another position, that is b here. So small displacement will take place. If small displacement will take place from the position of the body A. Let us consider here position of the body A here. If you do small work here, it will start changing its position to the next point. So that is that distance or that displacement, we call it as it is a dr. What work we are doing here? Small work, dw. Small work or the work done by moving the body from the position of A to the position of B, whether it will take place the displacement or not, whether it is possible to do such things to get escape from the gravitational pull of the earth or not. So let us consider the small displacement. So to get the small displacement, we have to do small work done here. So according to the Newton's law of gravitation, so what is that? Force of attraction between the bodies. Force of attraction between the body and the earth here. What it will be? G capital M small m by r square. R square means what here? Distance between the body from the center of the body to the center of the earth. So force of attraction or central force between these two bodies, from the center it will take place. That only the force of attraction between these two bodies are directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Now the main point is, already the body which we have considered here whose mass is a small m, it is just, I need to say that it is already maintaining certain height from the surface of the earth. If you just projected or if you just initiated, if you give the force, I mean to say that it has to be changed its position to get away from the gravitational pull of the earth. So that's why we are doing a small work here to get displacement of the position A, which is already certain height maintained from the surface of the earth. It will take the position of B here. So that is called as dr. Dr means a small displacement. dw is a work done here. So work done means what? Force into displacement. So force into displacement here. Right? Now if we are doing small work means dW is dW into force into dr. So we know F is what? dW. So dW small work is G and small m by r square here into dr. So to know that small work is workouting or not, that means small, if you do the small work, is that the body which is already certain height from the surface of the earth, it will changes its position and moving towards the position B means it is possible, means it is able to escape from the gravitational pull of the earth. It is having that velocity. Which velocity? That is escape velocity. If you do the work, then only it will escape from the gravitational pull of the earth. That only we are going to study here, how the escape velocity will develop on the body which is trying to get away from the or escape from the gravitational pull of the earth. So small work we have done here. Let us consider this is the equation 2. To get the total work done, so total work done to moving, work done to move the body from the radius of the earth to the infinity. I mean to say that, just clarify the things here. The body is moving from the center of the earth. I mean to say that force of attraction is between the bodies is the center of it. So that's why we are calling it as gravitational force of attraction is also a central force. It is the force attracts from the center of the body. So body, it is escaping from the gravitational pull of the earth means it is escaping from the center of the earth, attraction earth. So r to infinity it is. So it is moving from the r to infinity. So go ahead with the integration here. So we will get the how much total work we have to done to get escape from the gravitational pull of the earth. So integration of dW, integration of F. F means what? Force here. G capital M small m by r square into dr here. So integration of dW will be written as a W here, right? So integration here, I say it is from r to infinity. R means what here? Radius of the earth. Infinity means it will never be, I mean it is not in the control or not in the range of gravitational pull of the earth. So the body is trying to move from the gravitational pull or a gravitational force of attraction to the away from the gravitational pull of the earth. So it is not under the attraction here. So it is trying to go away from them. From which point it is? From center of earth to infinity here. Now that's why we have taken the range here r to infinity. In earlier topic or earlier discussion, we have studied here the body is bringing from infinity range to the particular gravitational field. So we are doing the small work there also. So what we are getting? We are taking that body which is away from the range of gravitational field. It has to be bring to that gravitational field. So here the body is not bringing, the body is moving from the range or the gravitational pull, from the gravitational pull to get away from the gravitational pull of the earth, means from the center of the earth to the range where it should not be under the gravitational pull. That is called as a escape velocity. Now with the help of integration, you know very well integration of x raised to n. So it is a general form of integration here, x raised to n plus 1 or n plus 1 divided by n plus 1. So what we have to do here? We will take out gm small m integration of r to infinity 1 divided by r square into dr here. So integration of 1 by r square can also be written as here integration of r raised to minus 2 here. So what will be the apply this form? We will get it here r raised to minus 2 plus 1 divided by minus 2 plus 1. So finally what we are getting? Minus of r raised to minus 1 divided by 1 here. So directly I will write it here dW is equal to minus of G capital M small m here, right? So 1 divided by r. So r raised to minus 1 can also be written as a 1 by r here. So then finally r to infinity. So r to infinity. minus G capital M small m, right? So final infinity, final minus initial minus. So 1 divided by infinity minus 1 divided by r. So what you will get? Minus minus plus which is there. So plus G capital M small m divided by r. So this is called as total work done. I am writing on the top. Just note down here capital M small m by r. So this is nothing but the total work done by the body to get away from the gravitational pull of the earth. This is not escape velocity. This is the total work done. So we have to do this much amount of work done, this much amount of work to do or to move the body from the range to the infinity here. So this work done will be converted into kinetic energy of that body. So this work done will be converted into energy. Now what it will happen? What is the kinetic energy? Kinetic energy will be half mv square. So we will write it here instead of v, ve. Ve means what it is? Escape velocity. So escape velocity. So this work done will be converted into kinetic energy of this body. Clear? Got it? Now what is work done here? We will do small work here to get a small displacement dr here. Once we got this, it is possible, the body is moving from small displacement, then we will calculate the total amount of work done to move the body from center of the earth to the away from the gravitational pull of the earth. So what is that work that we have got here? Total work done, W is equal to Gm small m by r here, right? Now that work done or that total amount of work is converted into kinetic energy. So this is the kinetic energy is equal to W. So half mv square is equal to G capital M small m by r here, right? Now next, so m e square. So the small m term small m will get cancels, remains with ve square by 2, that is Gm by r. Now EV square is equal to 2Gm by r. So it is V square. What we get here? V square is equal to 2Gm by r. Right? VE is equal to root of 2Gm by r. So what is the escape velocity here? I will write it here once again. So from the next point, VE square is equal to 2Gm by r here, right? So VE is equal to root of 2Gm by r. So this expression will give you the escape velocity of the body, which is VE is nothing but the escape velocity of the body which is moving away from the gravitational pull of the earth. So here, very important note here, that is acceleration due to gravity we know. So what is that? On the surface of the earth, G is equal to Gm by r. So what is acceleration due to gravity on the surface of the earth is Gm by r square. As we know here, the escape velocity is what? 2Gm by r here. So this is very important as per your competitive part here. So here I can write it here gr square by, gr square is equal to gm. Can I write it or no? Yes, it is possible. Now place the value of gm here. What you will get? Escape velocity root of 2 gr square divided by r here. What you will get here? R will get cancels. 2 root of 2g r. So what is this? This is nothing but the acceleration due to gravity. How it is related to the escape velocity of the body here. If you you will get? You can write it here 6.4 into 10 to the power of 6 here. Right? So what you will get? G is equal to 9.8 meter per second square. R is what? Radius of the earth. 6400 kilometer per second. So you just place these value and you will get the, what is the value here? Escape velocity 9.8 into 10 to, into 6.4 into 10 to the power 6. Finally we will get 11.2 kilometer per second. So this is the escape velocity of the body on the surface of the earth. If it is projected or if it is executing such kind of velocity here, this escape velocity we call it as 11.2 kilometer per second. If it has on the surface of the earth, it will try to, or it will get away from the gravitational pull of the earth. So this escape velocity is totally depend upon the mass of the earth and the size of the planet and acceleration due to gravity. This is very important. So how on point of escape velocity, it is dependent on which matter, which is independent on which matter. These things are very important. So escape velocity is totally depending upon the mass of the earth and the size of the planet and the acceleration due to gravity. It is totally independent of the mass of the body. So it will not depend upon the mass of the body. It is depend on the mass of the earth and size of the planet, acceleration due to gravity. If you consider the thermal velocity of gas molecules of the earth atmosphere, how they are less than this escape velocity, 11.2 kilometer per second. So that is less thermal velocities of gas molecules of earth atmosphere. They are less compared less velocity as compared to this escape velocity. So what it will happen? It will try to bond with the earth atmosphere or the earth it is. So we have a atmosphere. Earth has an atmosphere just because of this escape velocity. Those thermal velocities of gas molecules, those are there in the earth atmosphere. They are very bond to the earth because of their velocity is less compared to this escape velocity. So they are bonded with the earth. So we are experiencing the earth atmosphere. As you compare the thermal velocities of moon atmosphere, they are having what? Greater than the escape velocity of the moon atmosphere. So they are easily get away from the gravitational pull of the moon here. So moon doesn't has a atmosphere. So this is very important. They will ask you how they are related with the acceleration due to gravity, the escape velocity of the body here. Directly you can, if you remember this formula, directly you can apply and you will find out the value.